Let me go ahead and start off by introducing our speaker here. It's Jason Wright. I'm going to just read from this, so excuse me. Jason is an IT and security professional with over a decade experience across several industry verticals, such as critical supply chain within transportation and logistics sector, as well as the financial sector. Primarily, he is a security engineer, especially in SecOps, incident response and DevSecOps type work such as vulnerability management, defer web application pen testing, secure code review, and it keeps going on and on. This guy has a plethora of background here. Of course, he also possesses multiple industry standard certificates. He has a master's degree from UMGC, and he is also an alumni of Chesapeake Community College, where he also serves as adjunct faculty for the CST program there. He has a very vested interest. I want to put this in here in the IT talent here in Delmarva. Have seen firsthand how the talent shortage is affecting his area. He traveled all the way up from Sussex County. I want to point that out because I'm also from Sussex, and we don't get a lot of credit down there. So, well, without further ado, Jason Wright.
Thank you. Appreciate it. Thanks, sir. Morning, everybody. Thank you, Bert, for that great introduction. My name's Jason Wright, and one of the reasons I ended up deciding to kind of build this presentation out was because of over the years of how many IT sort of seminars I've been to. It's always kind of been a sales pitch or an idea or something like that. And I wanted to approach this with the idea of small, medium-sized businesses and some local municipalities coming in here and being able to obtain a free control, other than, just needing to basically, put in a bit of a time sink into it. So DMARC, a free control to protect brands is the gist of the conversation today. As Bert said, my name's Jason Wright. I'm not going to kind of go over everything. I do a lot of different things. I work as an incident responder for Blue Team Alpha. I'm a security engineer for regional management. I'm an adjunct instructor for Chesapeake Community College. So I kind of do a lot of different things. Over the years, I kind of found that incident response is kind of my forte. I like it when stuff's on fire. I like it when, people kind of start freaking out and they're like, hey, I don't know what's going on, or it's like a ransomware outbreak or something like that. I kind of like just jumping into things and just starting to fix stuff. My education background is mainly from UMGC. Other than that, I got I ended up going to Chesapeake Community College, and that's where I'm adjunct instructor now. Before we get too deep, show of hands, who knows what DMARC is off the top of their head? Who can speak to it? Okay, so we got a couple people. So a few people, out of you guys that do have it, are you guys at enforcement? You guys got P equals reject or P equals none? Anybody?
Just monitoring right now.
Just monitoring right now. So yeah, I did a little bit of research on the university's email right before we kind of came in here, just looking up their DMARC record on MX Toolbox, and kind of see they're kind of doing the same thing. Their record's set to none. So the goal of this conversation is to sort of talk about why you would want or need DMARC, what DMARC is, the different components. We're going to talk about actually configuring SPF. We're going to talk about configuring DKIM. Then we're actually going to go through a DMARC workflow, kind of going through the process of how email is going to be validated once you send it out. Then we're going to talk about the configuration of that, and then a brief touch on some of the DMARC forensics, because there is a bit of a PII concern there. We'll recap everything, and then we'll talk about kind of approaching DMARC from a project management perspective, because for different organizations of different sizes, you're going to notice that it can be a much larger time sink than for one organization that maybe has 3 mail sending services versus another larger organization that might have 10 to 15 mail sending services. So why would you want or need DMARC? So Palo Alto's Unit 42 response, I'm a big fan of Palo Alto, a big fan of Unit 42 and some of the stuff that they come out with, basically said that business email compromise, other than ransomware, are probably one of the biggest things out there. Beyond that, business email compromise heists, on average, earns cyber criminals on about $288,000. really, domain spoofing, typo squatting, phishing attacks, these are typically what led to the initial business email compromise, the initial BEC. So how can we help to prevent that? Well, that's where DMARC comes in. The best part about DMARC, it's a free control. It protects your brand from email spoofing to an extent. Whoever you're sending to has to also have policies validating those lookups as well. But it's used to protect your brand from email spoofing. Anybody applying for cyber insurance, I'm sure that this was probably something that came up on your cyber insurance questionnaire. Right now, cyber insurance companies typically just want it set to none, just to know that you have something out there, but eventually we'll probably see that this comes out to the minimum requirement being enforcement. Beyond that, verifying that you're validating SPF, DKIM, and DMARC for inbound emails. It's one thing to set this for your customers when you're sending emails outbound, but you have to also make sure that you're validating your own customers or your own sending services and things like that coming inbound. Okay. Beyond that, typically inbound rules for validating these lookups are not configured by default in many email security gateways. Office 365 is one of those. So what is DMARC? DMARC is domain-based authentication reporting conformance. DMARC is a really good way of just shortening it up, right? So RFC 7489, you want to do some light reading on that. It builds on the SPF and DKIM protocols, which we'll touch on right after this slide. But the purpose of DMARC is to give policies for message recipients to follow. We're going to give them a policy that says, hey, if this email fails SPF and a DKIM lookup, we're saying do nothing with the email. P equals none. You also have the option for quarantine, so P equals quarantine, where you would say, hey, if this email fails SPF and a DKIM lookup, we're also saying to go ahead and throw that email into your own quarantine, your admin quarantine hold. Beyond that, you can set it to reject, and what reject is going to do is going to be a straight up bounce. You send an email out to somebody, it fails the DKIM or the SPF lookup, it's going to the recipient's going to bounce that email. You are telling the recipient, this is your organization, your DNS records, saying you're telling the organization that's receiving your emails to straight up bounce that email because it is not conforming to something. Maybe it's coming from a sending server with the wrong IP address, and we'll kind of talk about how that gets configured. So we have these three different policy values. In the end, DMARC is going to protect your brand. It should be configured for all PARC domains as well. This was something that kind of came up here for me on my last cyber insurance renewal, is that defensive DMARC and SPF records are becoming a main, a big thing, because some of these PARC domains, just because you have them parked, does not mean that a sender can't necessarily go out and just start spoofing that domain and just start sending emails out on behalf of that domain, right? So the record is published in DNS. This is completely easy. You guys already should have your DNS up, running your websites and stuff like that. So this is just a text record that gets thrown into DNS that anyone can look up, and it's, other than the time sync, it's completely free to implement. So DMARC is made up of two separate components. The first one is Sender Policy Framework, or SPF. It was formerly sender permitted from, where it would use the from header. It still uses the from header on your emails, but that was the term that they used back in the day. So it is a path-based email authentication technique, which basically specifies which IPs from your organization are allowed to send on behalf of your org. So if you're sending from Office 365, your SPF record's going to likely be underscore Microsoft NetBlock, something like that, and it would have the Microsoft's DNS record in there. Otherwise, if you have on-prem Exchange or something like that, and I feel for you guys if anybody does have on-prem Exchange, if you have on-prem Exchange, it would be your outward-facing IP for your Exchange server, right? So with SPF, you're essentially saying which IP addresses are authorized to send on behalf of your organization. That is the TLDR of SPF. This started as an experimental protocol by the IETF back in 2006 as RC 4408. And then it was updated in 2014, and it looks like SPF is going to be going through another revision here soon with SPF v2. So DKIM, right? This is the other component of DMARC. So DKIM stands for Domain Keys Identified Message. It is a signature-based authentication mechanism. What this does is, as your email progresses through an email gateway of some sort, whether you have Mimecast, Zscaler, you name it, if you're just using Office 365, they have it in there, or Exchange Online. It is going to put a encrypted signature basically straight into the header of the email. So when somebody receives your email, they can run a DNS query and verify that that email came from your organization based on that encrypted string. This is based off the domain keys, or DK signature, which was based on email authentication developed by Yahoo back in the day. Something we can actually attribute to Yahoo, so good for them. Documented as RFC 4870. This was, this was the original. DK was the original. This was superseded by DKIM, and then it was introduced as DKIM in 2007, and then updated in 2011. I believe DKIM might actually be going through an update here soon as well with the updated SPF. So, long story short, this tells the recipient that the email came from trusted infrastructure because you are putting that encrypted signature header into the email. And if it gets altered in traffic or anything like that, it's going to cause that lookup to fail. So configuring SPF. So here's a couple examples. And granted, all of this stuff is available online. I'm a big fan of MX Toolbox. It's a completely free utility. You can run DMARC lookups and MX lookups and all kinds of stuff from there. Long story short, is SPF here. So this is just an SPF lookup for Google. And we have a whole bunch of symbols and stuff kind of going on here. At the end, we're going to see all. And what we're saying there is that all always matches. Whatever's in here, we're telling you to always match whatever we're putting in this. So this is going to be a text DNS record right here, where we're specifying which IP address. Now, this can also be a CNAME, which you kind of see up there with _spf.google.com, and I'll show you what that looks like on the back end. So the V stands for the version. All is going to be always matching. A is going to stand for that the domain has an A record, IP4, IP6, those are pretty self-explanatory. And then over on the far side, you can have MX records, PTR records. You should definitely avoid PTR records. It becomes a recursive lookup and kind of just complicates the whole thing. Most people, most organizations do a combination of either just having like a CNAME and pointing to a long list of IPs, because of the RFC limitation, or just listing out their IP addresses or their particular ranges. These are private ranges here, but this is just used as an example. Some other flags you might see are things like exists, which resolves to any address. That's going to cause your SPF rule to basically automatically pass, and then include. So include references the policy of another domain. So if you're using like Mimecast or something like that in order to use them as like your email gateway, your SPF rule is going to say include Mimecast dot whatever their MX records, I'm sorry, not their MX records, but whatever their SPF record's going to be, because they're going to be the outward facing IP, right? They're going to be the IP address that your customers see on behalf of your org. So there's a couple qualifiers at the end. A plus is going to equal a pass result. We're basically saying, hey, go ahead and pass that. Equal is going to be neutral. Our little squiggly line is going to be a soft fail, and then our straight dash is going to be a hard fail. The main difference, you really don't see people using question marks or the plus signs very often. Most of the time, you're either going to see a soft fail or a hard fail. Soft fail, more than likely, if it fails, it's going to go to like some sort of admin quarantine or something like that. Where if you do have a hard fail, it can still go to admin quarantine. Just depends on the receiving organization, but typically that would also result in a bounce. So here's an example, MX Toolbox, super easy lookup. You just go to mxtoolbox.com. They have a nice little drop-down box that has SPF. You just type in google.com, and then sure enough, it resolves right back to this. It shows that, _spf.google.com. Well, it's like, hey, that doesn't really give us a whole lot of context on what's sending on behalf of the organization. So in the background, we can see that they're doing these lookups to these net blocks that they have set up. And this is because of a limitation that SPF has that basically says you can't have more than 10 IP addresses in a single lookup. So this is a hard limit. So this is a way to kind of work around that hard limit. Large organizations like Google, Amazon SES, and things like that, they're going to use very similar schema to this in order to try to get their entire IP ranges in there. So what does this resolve to? So here's just the very first NetBlocks block, bunch of IP addresses and ranges in here that they're basically saying, hey, these are all the IP addresses that we're saying is safe to send on behalf of our organization. So this is just an example of Google's. So DKIM, right? So DKIM, domain keys identified message. So here's an example. Contoso is our typical Microsoft, testing domain, right? Here we have, again, a whole bunch of numbers, letters, symbols, and things like that. I tried to break it all down. This whole slide deck, I'm not going to, you guys don't have to take a picture of this. This whole slide deck is going to be available online. But what it means, and the big ones I want to highlight are selector, the domain, and the from domain and message. And then sometimes you might see an actual body hash as well, where DKIM will actually put a signature into the body, and you can tell whether or not the body's been altered in transit. So V stands for version. A is going to stand for the signing algorithm. Here we have RSA SHA-256. D signing is a domain identifier. Just basically it signifies what the domain is. And then S is our selector. The selector is important because that's what you're going to use to actually look up the record in MX Toolbox or something like that. That is going to be what you put in DNS in order for people to kind of verify that record. So that selector gets pulled out of the email header once somebody receives the email from your organization, and they take that selector, do a lookup in DNS, and verify that that selector corresponds to an encryption key that's in DNS, right? And then there's a bunch of other values in there too. There's a lot of optional values as well, things like timestamps and stuff like that. The email is already going to have timestamps and things like that. So kind of like getting into, so here's like an example from Chesapeake that I used. This is just an example header. So DKIM pass header, we can see the domain is at chesapeake.edu, right? The header selector 2. So selector 2 is going to be, the selector that we're going to use to actually look this up. That B value over there is going to represent the body hash. And then we see this ARC value here, which we'll kind of talk about ARC in the, at like towards the end. ARC is a Microsoft standard that they came out with in order to try to support inner tenant, within the cloud, within Office 365, different Microsoft organizations kind of send in on behalf of one another, because the emails don't technically leave the Microsoft bubble. So they had to kind of find a way to make DMARC work, and so they kind of use ARC for that. So kind of going down this list, we can see, from this header, ARC pass, the domain DMARC passed, right? And then the from domain, and then the SPF record, and then we can kind of see that, the college that I'm working at, they have their P equals none. This is probably what a lot of people here have, right? So kind of moving on, we take this selector, right? So we have selector 2, and we do a DKIM lookup. The syntax for this, I have it in the slide deck. It's going to be the domain, right, colon, the selector, and then that's what you're going to throw it in the MX Toolbox as. And you're going to take that, and if it comes back green, it means you're good, right? What do we know? We know that it's using DKIM version 1, it's using an RSA key, and then there's the encryption, the public key that's being put into the email so that we can verify that. This is an example of DKIM passing, right? So this is what good looks like. So let's talk about the DMARC workflow. So you sit there, you compose your email, send in mail server inserts the DKIM header. So if you send this email out via Mimecast or whatever, it's going to insert this header straight into the email, and then it's going to be sent to the receiver. When the receiver initially gets it, the first thing you're going to hit is like IP blocks, reputation blocks, rate limits, stuff like that. Normal spam checking, stuff like that. Once you get through that, this is when DMARC comes in, and it's going to start authenticating against DMARC, DKIM, and SPF. The first one it's going to do is DKIM, right? It's going to retrieve the DKIM domains, and it's going to do the DNS lookup and see whether or not those pass. If those pass, it's going to go ahead and move on. So then it's going to retrieve the envelope from via SPF. So it's going to find the envelope from header and that IP address that corresponds to that server, and it's going to say, hey, is there a DNS record that specifies that this IP address is allowed to send on behalf of the domain? And then sure enough, if that passes, it's going to, or fails, it's going to apply the appropriate DMARC policy. So this is where we are telling our recipients what to do with these emails. We're either telling them, hey, this passed, go ahead and just take the email, you're good. We're going to say, hey, this email did not pass, go ahead and quarantine this. And this is us telling them that. Or we're saying, hey, we have such a tight hold on our sending infrastructure that you can go ahead and just bounce this email. If it's not from us and none of these values pass, go ahead and just bounce that email. And then at the end, you know, it's going to go through standard processing, anti-spam filters based on the user and things like that. So here's an example of a DMARC record. So this is what you would put up in your DNS up here. V equals DMARC 1, P equals reject. I would not go to reject if this is your first dabble with DMARC. Definitely go to none. Get your forensic records going. We'll kind of talk about that. But this is the general syntax that you're going to be looking for. There's going to be RUA records. These are forensic records, and you're basically going to point them to either a mailbox, a distribution group, or a forensic log aggregator. These tags over here kind of listed on the right, so the V basically stands for the version. The percent is the percentage of messages subjected to filtering. So you can basically specify if if you don't want to have 100% of your emails subject to filtering and you're still trying to test this out and try to get it working right, you can set it to be like 20%. You can set it to be 10%. You can set it to be 50%. You can set it to be whatever threshold your organization is going to be tolerant of. RUF is going to be reporting URIs for forensic reports, so that's a forensic report. RUA is also going to be another forensic report. And then P is going to stand for the policy, where we're going to basically say, hey, P equals quarantine, P equals reject. SP is a policy for subdomains. If you have a bunch of subdomains, you would use an SP policy. And then you can set certain strict or relaxed DKIM and SPF alignments. Essentially, you're all like, once you have a real fine tune or a good hold on this, you're going to set this to strict all the time. You're never going to, and by leaving those two bottom values out, it's kind of why I put them down at the bottom, it's automatically going to default to strict, and it's not going to default to relaxed. So here's the forensic records. So the purpose of these forensic records is so that your email admins have something to troubleshoot with. Let's say you have a very large organization with tons of different senders, and you have no idea who's using what, and none of your DNS has been really kind of kept up to date. What you would need to do is set these aggregate reports to come to you. Now, sometimes, there's different aggregators out there. DMARC has one, DMARC Analyzer has one. I'm not pitching anyone in particular. There's a couple. If you have Office 365, ValiMail is completely free, and you can use that. So there's a lot of free resources out there in terms of just like bringing in that data. These reports come over as an XML file. And nobody wants to sit there and stare at XML files all day. I have to sit there and look at JSONs all day. No one wants to sit there and look at XML all day. So what can we do to make this easier on our admins? We can send this stuff to a free aggregator. And what that's going to do is going to take all of these forensic reports and it's going to dump them into a really easy format, typically a nice little graphical GUI, where you can sit there and see which IPs are sending on behalf of your organization. And it's going to tell you what your passing or failing rate of DMARC is. And you can use this to help troubleshoot. If you see some random IP and it's Amazon SES, and turns out your marketing or like we all have marketing teams, so let's throw Salesforce out there. We all have Salesforce, and they need to be able to send emails all the time, and they never told you that they needed this set up the right way. So what you could do is like, hey, IT just set it up for them. You go back, you can use this to kind of take a look. You'll be able to see that these emails are being sent out, and you'll be able to see that they're failing DMARC, even if the policy value is equal to none. So if the policy value is even equal to none, you're still going to get these forensic reports. You can use that to troubleshoot in order to progress to the point where you can set that policy value to quarantine or set that policy value to reject. So big thing here is that on the far right side, you almost rarely ever want to use RUF reports. It's going to have the specific details of every email sent almost immediately after the failure occurs, which sometimes that can be beneficial. The issue is that it's plain text, though. It's not encrypted. This is not encrypted at all. So it can contain PII. If this is like an email that left your organization from your HR department or something, this could contain PII, and it's in plain text, right? Not encrypted. Super big no-no. We don't want to do that. So typically, don't even use RUF reports. RUA reports are going to be aggregate reports. It's going to take if I was sending an email to Sean over here, I'm gonna just use it for an example, and I sent him 1,000 emails a day. At the end of the day, he's going to send me an aggregate report back with all of the details for every email I sent to him, and then I'm going to be able to use that to help troubleshoot. Again, this does come over, it's not real time. They're sent every day by default, and you can increase or decrease that depending on, where you're at with your DMARC journey. It's set in XML format. Again, nobody really wants to look at that. But there's no PII, so there's no real risk with this. It's just helpful troubleshooting data. So it's supported in all DMARC compliant mailbox providers. What that means is DMARC aggregators, something like ValiMail and something like that.
Yes, we got 20 minutes.
Okay, 20 minutes. Okay, so we got time. All right, so here's an example of what these forensic reports kind of look like. Date and time range of the reports, the report name is going to be first thing kind of up there at the top, and then the date and time of the report. And then, we're going to say, hey, what is the DMARC policy of the domain being validated, if it's set to reject, and what the percentage is. And then we're going to start finding really fruitful information. The sending IP address, right? That's going to be like one of the first things we're going to look at in order to determine, hey, who owns this IP? What's the sending service? Did marketing just stand up something kind of brand new? And then we're going to sit there and take a look at the SPF DKIM pass-fail results. Did it pass? Did it fail? Why or why not? And then down there towards the end, we're going to have the alignment results showing whether or not it, the nitty-gritty breakdown of whether or not it passed. So here's an example of a DMARC configuration from Google, where the version is equal to 1. They feel really strongly with their email sending platform, so they're saying, hey, we're going to tell you if this email fails the DMARC lookup, we're telling you to reject that email. And then they're pointing their RUA records, their forensic records, to mailauth-reports@google.com. It gives them a place to aggregate this data so that if they do start having problems, they have the opportunity to troubleshoot it. So long story short, when it comes to like DMARC forensics, point them to a log aggregator. No one wants to read XML files all day, determine who's sending them what. Tons of DMARC analyzers and aggregator options out there. If you Google some stuff, you'll at least get a free trial for 30 days. That'll give you something to use for the time being. And then these services typically provide a graphical UI to analyze this information. It's typically free. Usually they cut you off around 2 to 5 domains though. If you have more than 2 or 5 domains, they're going to cut you off and want you to pay for something. And then down here, I have a couple lists of, a list of a couple of them: ValiMail, DMARC Analyzer that was bought by Mimecast, DMARC-in, and there's a bunch of others out there. So, we talked about why you would want a DMARC record, what it is, the components of DMARC, how to configure SPF and DKIM, and the actual DMARC workflow configuration and lookup. So let's talk about like the project management perspective of this, because depending on the size of your organization and the number of senders you have, this can be a rather large lift and might take several meetings with a couple different stakeholders in order to determine who's sending what, or why are they sending it. So first things first, decide on an aggregator. That's the first thing you need to do. Figure out who you want your aggregator to be and just start using it. There's too many free services to stare at XML files all day. And then you're going to set up your first initial DMARC configuration. P equals none, and then you're going to point your forensic records, your RUA records, to the aggregator. And just wait for those logs to trickle in. It's going to take a week or so, but in order to get like a really good picture, you're going to need about 30 days. And then you're going to verify your position for SPF and DKIM. So right now, these first 2 bullets, all we talked about was figuring out who your aggregator is going to be, and then setting up your initial DMARC record. And then, we haven't even done anything with SPF or DKIM yet, right? We're just trying to get those logs flowing. And now we can start to verify our position on SPF and DKIM. You need to know your senders. So check DNS. There should be SPF records for each sending service. It depends on how your organization has separation of duties. In my organization, I can't really touch DNS. I'm just sitting there doing lookups, right? So you want to check DNS, make sure SPF records are in there for each sending service, and a corresponding DKIM record. Both of them have to go together. If you're using Salesforce, you need to go into the Salesforce platform, create the DKIM key via their documentation, and then take that DNS record and you put that DNS record into your DNS. And then verify verify your position on validating inbound SPF, DKIM, and DMARC lookups. If another organization is going through the legwork of configuring this, you owe it to them to at least be validating those lookups. Office 365 does not validate this stuff by default. So if you're on Office 365 or Exchange Online or something like that, you're going to have to go through and manually set that up. All that is just basically a checkbox saying, hey, we're going to start validating SPF, we're going to start validating DKIM, we're going to start validating DMARC, and then we're just going to compare that to what they have posted. And if it fails, it fails. Now, the best part about you being, it being on your side of the wall is that you can set up what happens. You don't necessarily need to bounce an email just because somebody had P equals reject. What you can do is just take all that stuff, put it on admin hold, send that stuff into a black hole off to the side so that you could sit there and take a look at it later in the day. Maybe you grab some threat intel or something like that from it. You might be able to find some naughty IPs or something like that from it, right? So verify your position on validating inbound SPF, DKIM, and DMARC lookups. If someone's going through that legwork, pay them the courtesy of looking up those records and making sure that you're trusting where those emails are coming from. And then again, depending on the size of your organization, open discussions with marketing or IT. Typically, it's marketing that's going to be sending up these external senders really fast. On developing and maintaining a list of senders and records in DNS. And then once you guys get this straight, it's kind of like a set it and forget it type deal. It just depends on how often your environment changes, how often you bring on a new sending service or something like that. So, these records should be audited yearly, depending on the environment. If you have a lot of changeover or something like that, maybe do it a little bit more frequently. Keep in mind that if you do have a lot of senders, and I'm kind of hitting this wall myself with my own organization, is that SPF has an RFC limit of 10 IPs before you have to start doing what Google did in order to do like some CNAME lookups to kind of go down that trail in order to try to get all of their IPs to fit. And then obviously remove any stagnant records. If somebody goes through and offboards a vendor, like it's like, hey, we're no longer using Salesforce or anything like that anymore, make sure you go through the work and go in there and delete those DNS, those DKIM records and those SPF records, take those IPs out of there so that Salesforce can't send on behalf of your domain anymore, right? So once all records are validated and no failures are being seen via the aggregator, right, we're going to set that P value to quarantine and percent to XXX, whatever the organization's tolerable of. P equals quarantine. Like if you don't use the percentage, that's fine. It's going to default out to 100%. But quarantine is going to be that first step, and quarantine's fine. If you get to quarantine, that's enforcement. You're telling people, hey, this email did not come from us. I am telling you to put it in the quarantine. It's up to you to put it in the quarantine at that point. If they're not doing their legwork and validating the inbound rules, then it's kind of on them. They just took in a bad email, an email that was spoofed or something along those lines. And then eventually you want to get the P equals reject. That should be the end goal of any DMARC project. So DMARC is a journey. The larger the environment, the longer the journey is going to be. Once it's configured, all you have to do is maintain it. So a couple honorable mentions. Microsoft Defender ARC. ARC will help reduce SPF, DKIM, and DMARC delivery failures that happen due to legitimate indirect mail flows. And by that, we mean different senders all using Office 365 within the same bubble. This is where ARC comes in order to try to make that work, because it's basically Microsoft sending email to itself, right? So think cloud to cloud, tenant to tenant. This is configured by Microsoft and most cloud providers. And that's it. Anybody got any questions? Go ahead.
I want to go back to SPF for a second. You had mentioned the whole DMARC situation, trying to really dive into it. You had mentioned that you use Microsoft as an example, saying that when you're dealing with the sending, what IPs are authorized to send, if you're dealing with Microsoft 365, it's sort of sending from there. Does that the same for Google Workspace? That's what we use. And so my concern would be if someone is on a mobile device or a phone, on the web somewhere else, if they're logging into their corporate Workspace email account, it does Does Google sort of work the same way as Microsoft? Or do I have to worry about all these
No.
possible
So
IPs?
it's going to be whoever you're sending services. So like, let's use this in the office, in the case of 365, right? A lot of people use Office 365 or Exchange Online or something along those lines. Because that is your sending service. That is the IP, Exchange Online, Office 365. That is the sending service that's sending on behalf of the org. It's only those IPs that you need to have in that SPF rule in order to sort of progress. You don't need to sit there and worry about, if your users are logging in via some sort of VDI or some workspace or some virtualization thing. Just because they're signed into a client doesn't mean that the email is coming from that client. The email is coming from the sending infrastructure that Microsoft has set up. So that's the only IPs that you really have to have in there.
Okay.
Okay.
For DKIM and DMARC, we just started to go down that path, that Office 365 environment, figure out how to generate the codes from that. But you mentioned that there's a setting within Office 365 to check for DMARC
Yes.
and DKIM.
So that's an inbound.
And can that be done, I'm assuming that can be done separate?
Absolutely. That can be done separate. So let's go back to Microsoft and 365 for a minute, just because I'm kind of used to it. So 365 by default has DKIM sort of set up. The issue with them setting it up by default for you is that you do not have control over those encryption keys. On top of that, those encryption keys are using 1040 or 1024 or whatever the basic encryption is versus using like 2048 or something like that. So when you go into Office 365, so two things. The inbound, yes, the inbound rule set is completely separate from your own config. So that answers that question. Number two, you should want to be in control of your own encryption keys. You don't want Microsoft to be in control of those. Somebody gets in there, if they grab a hold of those keys, they can do whatever they want to with them. So do the legwork, configure the policy manually in Office 365, and you're not going to really hit any bumps. It's going to be real seamless, but you want to be in control of your own encryption keys. Okay. Anybody else? Go ahead.
Have you ever seen log aggregation with like Elasticsearch?
Elasticsearch? Not necessarily. That might be, there might be like some GitHub repo or something like that out there that utilizes
I
that.
was kind of wondering if there's any validity to doing a large trend analysis. Is it worthwhile to look at the logs from more of a trend stuff, or individual violations are more important to look at?
I would say in the beginning of the journey, you're going to have a lot of noise. There's going to be a lot of noise and not a lot of signal. And it's because, granted, it does depend on the size of your organization. If you have a really large organization, there's going to be a lot of noise. If it's real small, it's not going to be a lot of noise, but there's still going to be noise. So you have to filter that out first. You have to figure out who can send on behalf of our organization, and then kind of take it from there. In terms of looking at long trends, for your particular org, maybe not, but for, a big sending service, let's think Office 365, something that scale, they do publish, some reports out there that'll say hey, here's where we're seeing a lot of spoofs coming from and things like that. So I would probably, in terms of a long-term trend, I'd probably look at something like that. However, some of these other aggregators, they'll hold your logs for 365 days. They'll hold your logs for an entire year. So you can get a 30-day snapshot, a 90-day snapshot, and then if you want a whole year snapshot, you can see a whole year snapshot to kind of show the whole journey that you took. So I don't necessarily know if there's something out there for Elasticsearch to be able to kind of comb through that stuff. There might be like a GitHub repo or something like that out there. But I'd probably just kind of leave it up to the DMARC analyzers people. Your engineers have a lot more, are worth a lot more money than to sit there and kind of comb through those logs once you kind of get it set up straight. Anybody else? Okay. My name's Jason Wright. I appreciate you guys coming. This slide deck's online. If you guys want to take a look at any of this, and it has a whole bunch of links to a bunch of documentation to kind of help you guys through that journey. So I appreciate you guys all coming out and listening to me in my TED Talk. Appreciate it. Thank you.